Okay, so today we're going to talk about percent composition. This is a little bit further down your notes. So if you guys can find the section where it says percent composition and chemical formulas, we're just going to talk about percent composition today. So here's the definition for a percent composition. It's the percent by mass of each element in a compound. I got two sample problems here to work at. Let's start with the first one. So sample problem number 1. 8.2 grams of magnesium is combining completely with 5.4 grams of oxygen to form a compound. I want to find percent composition. So to do this, let me see what I have from the problem. So magnesium is given as 8.2 grams. Oxygen is given as 5.4 grams. All right, so just like how we normally find percent, well, percent is out of 100, and here we need to know what this is out of. So I'm going to add them up to get a total. So 5.2 plus 5.4, or 8.2 plus 5.4 is equal to 13.6 grams. Okay. And then just like how we normally find percent. So to find percent for magnesium, I'm going to take the amount of magnesium, which is 8.2, and then divide it by the total, which is 13.6. And let's see what we have on the calculator. So from here, I have 8.2 divided by 13.6. From here, I got 0.603. We're going to round to 3/6. And since we're looking for percent, I'm going to move my decimal to the right twice or multiply by 100. And this will give me 60.3% in magnesium. And we will do the same thing for oxygen. So for oxygen, I'm going to take the amount of oxygen, which is 5.4 grams, and then divide it by the total, 13.6. And here I have 5.4 divided by 13.6 on the calculator is given as 0.397, rounded to 3/6. And again, you either move the decimal to the right twice or multiply by 100. And here we have 39.7% in oxygen. The answer should add up to 100 because this is out of 100%. Okay, so that's the first example. Now let's look at the second example here. So this second example is asking us to calculate the percent composition for C3H8. Now for C3H8, those are all the information given. We don't have any numbers. So to get the percent, which is all numbers, we have to get the numbers somehow from our chemical formula. Okay, I'm going to change my pen color really quick here. All right. Okay, so this is just like how we found our molecular weight a couple of days ago. So according to this formula, I have some carbon. I actually have 3 carbons, and I have hydrogen. I have 8 hydrogens. The mass for each carbon, according to the periodic table, is 12. So I'm going to multiply 3 carbons, will give us 36. And then hydrogen, according to the periodic table, the mass of hydrogen is 1. So I'm going to take 8 multiplied by 1, and I have 8. So add them up to get the molecular weight, which is the total. Up to be 44. All right, and then the rest is just like the last problem. I'm going to take the amount of carbon, which is 36, divided by the total that I have on the calculator. It gives me 0.818. Okay, and I'm going to multiply by 100. So this would give me 81.8% in carbon. And then hydrogen, take the amount of hydrogen divided by the total. here I got 0.182 rounded to 3 sig figs. Multiply by 100, and I have 18.2% in oxygen. Okay, and let's make sure our answers add up to 100, and they do add up to 100. So we're good here. Okay, so that's how you find percent. I want to do a couple more sample problems from your homework, just to make sure that we're on the right track. So let me find a couple questions from your homework. Okay. All right. I want to do number 1A and 2A. Right, so number 1A is just like our last sample problem that we did. So we're gonna go ahead and find the molecular weight. So here I got 2 carbons. And each carbon has a mass of 12. So 2 of them will be 24. And the hydrogen, I have 6. And each hydrogen, according to the mass on the periodic table, is 1. So I'm gonna multiply, and I got 6. Now my total for this comes out to be 30. All right, and then to find the percent composition for each one. So for carbon, it's going to be 24 divided by 30. And I got 0.8, which is the same as 80%. So 80% is carbon. And for hydrogen, 6 divided by the total is 2, which is 20%. Okay, so we're done with question number 1, or question number 1A. Now let's look at question number 2A. So it's asking us to use the answer from the last question to calculate the mass of hydrogen. All right, notice 1A and 2A, they have the same formula, C2H6. We already found the percent. So the question is, how much out of 350 grams will be hydrogen? Since earlier we said 20% is hydrogen, so all I have to do is find 20% of 350. So to do that, we're going to take 350, 20% change into decimal is 0.2. All right, so I'm going to multiply, and I got 70 grams. So 70 grams out of 350 is hydrogen. The rest, which is 280, will be carbon. Okay.